Good morning, all. I'm Lasya Priya. Although my name is long, you can just call me Lasya. And today I'll be presenting on data cleaning and processing. But before I delve into the topic of data cleaning and processing, I would like to describe about how we can picture data in a KDD pipeline. What is the full form of KDD? It's Knowledge Discovery Database. So the first step is data collection and extraction from various sources, such as SQL and public libraries. The second step is data profiling. And as you mentioned before, in data profiling, what we do is we understand the basic statistics of the data. You need to understand your data before you process it further. So you'll be understanding what data you have, what kind of columns do you have, what are you dealing with exactly. The next step comes processing. And I think that although there are many other stages, I think that processing is the most important one. The next comes the data mining. Sometimes we confuse data mining to KDD process because whenever we do a a data mining project, we encounter all of these steps. And the last one is data analysis. Generally, what clients need or what we are expecting from this entire pipeline, that is the end result is an analysis. We need a final statistic. What can I gather from this, the whole process? What am I getting out of it? But to get a proper one, we need to follow all of these steps. And sometimes um, we keep, why exactly do we even need cleaning and processing? Imagine you enter a library and the books are all over the place, everything is piled up, and you see a lot of cobwebs. So even your data is something similar. What do you do when you enter such kind of a library? You start segregating them in terms of fictional, non-fictional, horror. You categorize them basically. And later you start cleaning out the cobwebs. Similarly, even in this data, when you're given a raw data set, you try to understand and you try to transform the unstructured into a structured format. And for cleaning, you try to identify what is going on wrong and you try to correct them. You try to figure out what is exactly wrong with the data. So let's say, as I said, I'll be using this library example throughout my presentation. You can actually visualize what is wrong with the library. And over the process, you'll be understanding that you might have to go back to what you have done before, and you'll have to reiterate the same steps. Similarly, throughout the KDD pipeline, you might have to repeat some of these steps. You might have to profile your data. Sometimes you'll have to clean your data, transform it, and even encode your data multiple times so that you can build a proper model out of it. And why do we even need to clean the data? So that we can reduce the risk of errors. We obviously don't want a fault analysis, right? We don't want a defect output to be shown to a client, or you don't want a wrong answer, obviously. So, and even to build your model, we need an accurate data set to begin with. We cannot imagine building your house on a rocky area. You need to smoothen it. You need a concrete layer to get started on building your house. And this is why we need a very clean and a processed data. Now, exactly, how can we identify the issues in a data set? Some of the common issues are your values are missing. You see that some of the, let's say, it could be confidential. You're taking a survey from someone, and all of these are missing. And there could be outliers. What do we mean by outliers? They're like rebels in a data set. And sometimes it could be genuine, and sometimes it could happen because of many discrepancies. And finding outliers and handling them is also one of the important tasks in cleaning process. The next one is duplicates. Let's say, I think all of us would have made this mistake while filling out a survey. You would have submitted your form twice with 2 mails or 3 mails, which is a which is like a duplicate record in your data set. The next one is inconsistencies. Inconsistencies could be like, let's say I come from India and we follow the convention of date, month, and then year. But here in the US, it would be month, date, year. What happens if we don't follow standard convention? We could be dealt with redundant issues, and also it becomes a fallacy. The next few slides, I'll be describing how we can handle each and every of these issues. Starting with handling missing values. And funny, the thing is, I just worked on this project last evening along with my teammates. We had a couple of NAN records, and we had to deal with it after after doing a transformation, we had to deal with NaN errors. So what did we do? We did mean and median imputation. So for imputing, you can take mean, median, or you can even fill it with mode. And the next one is forward or backward fill. What we generally do is we fill with a neighboring value so that you're not given any sort of error. The next one is you can drop missing rows, but this is generally not suggestible because you might be losing out on important data. This is suggestible only when you don't really require that data and you can proceed further with it. The next one, handling outliers. The first one is the z-score method, where a data point, let's say it is out of the range. What we are going to do is we take the data point and we see how many deviations it is from the mean. There's a lot of math going beyond it, but it's really fun when we see the practicality in your application while building a model. And interquartile range. Sometimes we generally build a model by applying these two methods. Also, there's visual detection where we use a box plot. And how do we detect outlier using a box plot? It lies out of the whisker. And yesterday, as I was saying about my project, we used all of these. Some of them, as we hear about it, the math behind it, it might seem like very complex. And some of these, like visual detection, the box plot, and this one looks like a elementary math method. So what I would say is it's nothing to be afraid of, or we cannot even disregard easy methods. When we put them together, we can understand how important it is to detect and handle the outlier. So using the box plot, we generated a range such that we could use that for a z-score. And using this, we could get rid of the outliers and we could get a clean data. The next one is with how do we deal with duplicates and inconsistencies? As I said, duplicates could be like the same record is being shown multiple times. Although in the recent times, there have been a lot of research going on dynamic data validation, where as soon as you enter your name and let's say some of the common records, it would be considered as a primary key and you won't be allowed to submit the form. That is dynamic data validation. A lot of research is going on and there's exciting opportunities in this field too. So by setting some setting some distinctions over these, we can make sure that it is unique and different and you don't submit the record twice. The next one is by using deduplication functions. Whenever you receive a data, you can apply some of these Python methods and SQL methods so that your the duplicate data is gone. And in order to deal with consistencies, let's say USA in cap small, sometimes it's even represented as US. We can represent it to a simple pronoun. So we need to standardize it to a easier format such that it's readable as well as standard across everywhere throughout the entire document. The next important step in pre-processing is data transformation and feature engineering. So now we are left with a clean data set. What do I do with this data set? You can transform it. Let's say, as I said before, we are taking library example. You would be labeling them in terms of category, genre, fiction, non-fiction, and everything. But can machine really understand that, okay, fiction or non-fiction? No, you'll have to label it. You'll have to convert it into a numerical value. Let's say 0, 1, 2. 0 means fiction, 1 means non-fiction. That's how the machine would be taking it. You'll have to interpret to the machine in that way. The next one is principal component analysis, which was covered by him in the previous section. So in principal component analysis, obviously, there's a lot of math behind text data transformation, principal component analysis, as well as data discretization. But we all need to begin with our data journey somewhere. For principal component analysis, we need a lot of matrix algebra and statistics. Similarly, even for text data transformation, some of the methods are one bag of words and TF-IDF. So all of these, it takes the frequency of the words and then it would represent it to the computer such that it can build a model. Data discretization. Let's say all of us here are of varying age groups and I'm like 23 years old, 9 months and something. but we don't really need that it's 23.9, 23.5. We are going to categorize it into something simpler. We'll be categorizing 0 to 10, 10 to 20, 20 to 30, and so on. Feature engineering is an advanced method where feature selection and encoding categorical values are important steps. For feature selection, again, here there are like multiple ways where you can select features. Do I really need to use all of these to transform my data? Obviously not. What you need to perform with the data is based on your intuition and your domain knowledge. Sometimes even your intuition helps. So I was working on a signal processing data set, and all I had was 985 files with just decimal points, and I had some information about bearings and the timestamps. Now, with this information, I'll have to search in Python libraries about how I can transform the wavelet, and then I implemented those feature selection techniques to get a transformed data set and encoding categorical values. After you label it, you'll have to give some sort of a code. One hot encoding, which was covered by him in the last presentation, is a technique for encoding categorical values. How do I decide what is the best practice in data cleaning? Automate as much as you can. Use tools like Excel sheets and SQL, and basically use all of the techniques to handle the errors, such as outlier detection, z-score method, IQR method. Try to visualize it as much as you can. There are tools like Tableau, from which you can visualize what your data is. And then profiling. As I said before, we are going to encounter, we'll have to perform all of these steps multiple times. So you might have to revert back to doing the same steps. Sometimes you might make mistakes in the data set. Sometimes you would have chosen the wrong feature, but you could always revert back to the previous data set and you can start with it again. So dynamic data validation is like where you're given a notification of whenever it finds inconsistency or a duplicate value. Anomaly detection is similar to outlier detection.